Okay, this is a short supplementary tutorial to help with the box model creation and use in USU STAT 1040 class. Okay, how to construct and use box models. Well, the first question is, what is a box model? The answer: a box model is a useful gimmick that helps you organize information in a problem that involves chance. Here's another gimmick you might be familiar with: the division symbol. That helps you organize the information in a problem that includes dividing. Well, a box model is going to help you organize information in a problem that involves chance. Well, second question: what does that mean? Well, a problem that involves chance is a situation where more than one result is possible, and which result will occur is unknown. A good example would be rolling a die with 6 sides on it, numbered 1 through 6. A bad example would be deciding which type of tile looks best on your floor. What's important in a box model is that we can list every possible result of the situation, like listing the numbers 1, 2, 3, 4, 5, and 6 for a single die roll. Those possible results are the things that we list inside the box in our box model. So let's try a few examples. If you were tossing a coin, you could either get heads or tails. So I've listed both of those outcomes, and those are the only outcomes possible when you toss a coin. If you are randomly guessing the answer on a multiple choice test question that has options A, B, C, or D, then one of those answers would be right and 3 of them would be wrong. So the possible results of that problem would be a wrong, a wrong, a wrong, or a right. If there were 5 people in a room named Mark, John, Carrie, Rich, and Joan, and you randomly chose one of those 5 people, then the box model would include all 5 names: Mark, John, Carrie, Rich, and Joan. If you were randomly choosing a colored card from a hat that contained a bunch of different colored cards, 2 blues, 3 reds, and 1 green, then you would list blue, blue, red, 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 and green. Okay, second question. So we can list the possible outcomes in a situation involving chance. How does that help us? Well, a box model will help us figure out the best guess for how that situation will work out on any single attempt, and how far we can expect our guess to be off if the problem is set up right. So let's go on and see how that works. By set up right, I mean that a box model is really only going to help you in a situation where the results can be assigned a meaningful number. Not all the situations in here we're going to be able to set up so that a box model will work, and I'll show you how to do it. Looking back at the examples we saw, some of them will be easy for assigning numbers to the results, and others won't. Heads, tails, tossing a coin. In the coin toss, we could look at it like tallying one result or the other. So tallying, how many times do we toss this coin and heads comes up, or tails, or whatever. So we could add a 1 to the heads result and a 0 to the tails, meaning that we're going to tally the number of heads that are tossed on this coin. Or if we wanted instead to tally the number of tails, we could reverse it. So our box model would then say heads and tails, and it'd have a 0 underneath the heads and a 1 underneath the tails. If we were doing the multiple choice question with wrong, 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 and right options, we could do the same thing by putting 0s underneath the wrongs and a 1 underneath the right, because we're assigning a tally of 1 to the result of a right guess and a 0 to each wrong one. Same thing, if we're randomly choosing one of these 5 people in a room, we might consider tallying, for instance, boys versus girls. And we'd put 1s underneath each of the boys, Mark, John, and Rich, and 0 underneath the girls. Or vice versa, we could put, say, tallying girls, we'd put 1 underneath the girls' names, Carrie and Joan, and 0 underneath the boys' names. For such a box model to be useful, the problem situation would have to ask for such a thing. Like I said, it will. Okay, if in this course, if we want you to use a box model, then the problem will present you with a task that you can put numbers to it like that. A tally such as a 1 or a 0, or other ways that we'll talk about in upcoming slides. Okay, randomly choosing one colored card from a hat that contains 2 blues, 3 reds, and 1 green. If you're going to do a tally situation on this, you'd have to say how many blues are we going to draw from this hat. But if we were going to set this up right, then we'd have to say, all right, if we're tallying blues, we'd put 1s underneath the blues and 0s underneath the others, or we'd have to do the same thing as we did for the named people, and assigning a 1 to the color we wish to tally and a 0 to the others. So if we were tallying the blues, we'd do that. If we were tallying the reds, we'd do that. And if we were tallying the greens, we would do this. Okay, next section. Once we have meaningful numbers assigned to the results, we can get on with the crucial part of the box model. It's figuring out how likely each result is in the box we've created and writing that down below each result. In the simple situations we've looked at, finding how likely the results are is done by counting and making a fraction. So, in tossing a coin, if we're tallying heads, one result out of the 2 results possible are heads, and the other 1 out of 2 are tails. So we would write these fractions for the likelihoods. 1/2 for the heads and 1/2 for the tails. So that's 1 out of 2 results are heads and 1 out of 2 results are tails. If we were going to tally the tails, we'd instead get 1 out of 2 results are heads, but that has a 0 underneath it now, and 1 out of 2 results are tails, which has a 1 now. If we were going to do the multiple choice test question, how many results are there? Well, there are 4 results possible, and 1 of them is right. So if we set that up, we would write it as a fraction out of the total number of results in the box, which is 4, and we'd put 1/4 would be right, and that means that 3/4 would be wrong. And we would write it like this, and this is critical in a box model. Notice that I did not write 3 zeros underneath the wrongs with 3 3/4 there. I wrote it as one result of wrong with a 0 underneath it and just wrote 3/4 underneath that. Okay? So, not like this. This is not the way to construct a box model. Okay, you want to lump the similar results that are zeros, you want to lump them all together with one fraction underneath them, like this. Suppose we were randomly choosing one of these 5 people in the room and we wanted to assign the likelihood that a boy is tallied. Then we count up the number of total results, which is 5, and how many of those have 1s underneath them. How many boys are there? There are 3. We'd get 3 boys out of 5 total people, and we would write the box model like this. Boys, 1 with a 3/5 likelihood. Girls, 0 with a 2/5 likelihood. Okay, now if we were tallying girls, girls would get the 1 for the tally, boys would get a 0. We'd just switch that 1 and 0, and we'd get 2/5 for the girls and 3/5 for the boys. Okay, same thing with the blues, the reds, the green cards in the hat. That if we were tallying blues, then there would be 2 blues out of a total of 6 cards, and we would write it. Blue would get the 1 tally, and 2/6 would be the likelihood, and others would be 0 tally, and we would get 4 out of 6, like that. Not like this. If we were tallying reds, we'd get this. There were 3 reds, so now we list reds. It has a 1 tally and 3/6 likelihood, and the others have a 0 tally and a 3/6 likelihood. And if we were tallying green, it would be a 1 green and a 1/6 likelihood, and 5/6 for the tally of 0 on the others. Okay, third question. So we've assigned numbers to the results and found the likelihoods of the results. What do we do now? Actually, you're almost done setting up the box model at this point. To finish, you just need to find the 2 numbers that describe what's in the box. Remember earlier on when we said what a box model was used for. A box model will help us figure out the best guess for how that situation will work out on any single attempt, and how far we can expect our guess to be off if the problem is set up right. So, These are the two numbers that we now need to find. One is the best guess, and 2 is how far off that guess is likely to be. In statistics, those two numbers have names. The best guess is called the average, and how far off is called the SD, or the standard deviation. With a calculator and a well-made box model, finding the average of the box, that's a quick way to write average of the box, is easy. What we'll do on each of the box models we looked at is this. Multiply the likelihoods by the assigned numbers, those tallies, and then just add it all up. So, in the tossing the coin problem, if we were tallying up heads, we'd say a tally of 1 underneath the heads and a tally of 0 underneath the tails. We'd have a 1/2 likelihood underneath the heads and a 1/2 likelihood under the tails. So the average of the box would be basically taking the 1/2 likelihood times the 1 for the heads plus the 1/2 likelihood of the tails times the 0 of the tails. Just add that up and we would get 1/2 or 0.5. Let's try this. Randomly guessing the answer on a multiple choice test question with options A, B, C, or D. For the multiple choice test question, the average of the box would be 3/4 times 0 plus 1/4 times 1. That is 1/4 or 0.25. If we were randomly choosing one of the 5 people in the room and we decided to tally up the number of boys, we would have 3/5 times 1 and 2/5 times 0. And that average of that box would be 3/5 or 0.6. Randomly choosing one colored card from a hat that contains 2 blues, 3 reds, and 1 green. Now again, if we were going to tally blues, we would go to the box model as we'd constructed it, and we'd have 2/6 times 1 plus 4/6 times 0, and that would give us an average of the box, which is 2/6 or 0.333. If we were tallying reds, that would be 3/6 likelihood times 1 tally for the red, plus 3/6 likelihood times 0 tally for all the others. And that average would be 3/6 or 0.5. In the colored cards box model, if we were tallying green, the average would end up being 1/6 times 1 plus 5/6 times 0, and that average would be 1/6 or 0.167. Now to find the second number, what we'll call the SD box, it's a quick way to write standard deviation of the box, we'll do a similar calculation. We'll start by finding the difference between the numbers that we assign to the results. We take the larger of the two numbers and subtract the smaller from it. Then we'll multiply that difference by a certain square root. The square root we're after is found by first multiplying the fractions or the likelihoods together, and then taking a square root of the answer. In the end, the whole SD calculation will look like this. You'll take the larger number minus the smaller number, you'll figure out what that is, and then you'll multiply that by a square root of the two fractions multiplied together. You got to do it in the right order, and you got to do it a step at a time. In the heads and tails, tossing the coin example. Okay, we have this box model set up where if we're tallying heads, there's a 1 underneath the heads and a 1/2 likelihood, and a 0 underneath the tails with a 1/2 likelihood. The SD of the box would be equal to 1, that's the larger number, minus 0, that's the smaller number for the tallies, times the square root of the two likelihoods multiplied together, 1/2 times 1/2. That would give you an SD of 1/2. Do it on a calculator. Make sure you remember your order of operations from algebra, that you should work the parentheses out first. There's a little practice with it, you'll get it right. It looks like this. If you wanted to know where the pieces go, the 1 minus the 0 times the square root of the 1/2 times the 1/2. Okay, for the multiple choice test question, we had this box model set up, and we would take a 1 minus 0 times a 3/4 times 1/4 square rooted, and that would give us an SD box of 0.866. If we did the tallying the boys, it would be 1 minus 0 times the square root of 3/5 times 2/5, and that gives us an SD box of 0.49. If we were to address the colored cards in the hat situation, and if we were tallying blues for that, then the SD box would be 1 minus 0 times the square root of 2/6 times 4/6. And that's an SD box of 0.47. So that's it. That's all I have to do in order to construct and use a box model. Actually, no, that's not everything, because there are actually 3 different kinds of box models in this class. But that is the bulk of the work that you have to do. For right now, if you can assign numbers to the results, like the tallies as we've done here, and find fractions for the likelihood of each result, and then calculate an average of the box and an SD of the box with those numbers, you have the bulk of work in a box model construction for this class already done. So until we get to the next videos, good job.